Here is the solution for question first of mock test statistics. What are the pre-required knowledge that we must be aware of? It's 180 degree is equal to pi radian. 1 degree is equal to pi upon 180 radian. Similarly, we can find the value for 1 radian also, but we will not go into much deep. When we multiply 2 on the both LHS and RHS side, we will get 2 pi radian is equal to 360 degree. This is what is required here, because when we add all the angles of pie chart, it will result into 360 degree. Now, how to construct a pie chart is equally important. So suppose that I'm having n number of observation here. So the first thing which I'll do is to find the frequency. When I found the frequency, next I'll try to find the relative frequency, and after finding the relative frequency, I'll multiply the relative frequency into 360 degree, and whatever the degree will come, I'll note down the reading, and according to the angle I'll construct my pie chart. Next, what is the formula for relative frequency? Formula for relative frequency is equal to given frequency, that given particular frequency, upon total frequency. Another thing that we must know is that when we sum total all the frequencies, when we add all the frequencies, it will result into the number of observation. It is here given that the total frequency is equal to 500. Similarly, when we sum up all these relative frequency, it will result in 1. The summation of all relative frequency will give 1, and the summation of all the degrees will be equal to 360 degree. So the important thing that we must know that the summation of all the relative frequency will give 1. Another thing is that summation of all the degrees will be equal to 360 degree. As we know that that statistician had calculated using the wrong formula. He put pi into Ri, where we know that pi is equal to 180 degree, but we must multiply the relative frequency into 360 degree. So instead of pi, he should have used 2 pi. Now given in the question that it's given that using this 2 pi minus pi times submission up to 9th relative frequency, he had calculated the 10th relative frequency. Likewise, he calculated the 10th relative frequency, and we know that the submission of the relative frequency result in 1. So we can break it and write like submission up to the 9th relative frequency plus the 10th relative frequency will be equal to 1, because we are having 10 number of observation. So from here we can say that the submission up to the 9th relative frequency equal to 1 minus the 10th relative frequency. So this is important. Now it is also given the value of the 10th relative frequency which he had calculated, and it is 1.02 pi, but this is not the correct value, although he had calculated using the ever formula. So we will try to put the value. So instead of writing submission up to the 9th frequency, we can write here 1 minus 10th relative frequency, which will result in 1.02 pi, as it is mentioned in the question. So we will try to solve this equation. I hope that up to this step it's clear to you. We used this 1.0 pi in the RHS side because it was given that he calculated the relative frequency of the 10th observation using that ever formula. Now we will try to solve this equation. It's pi plus pi times the relative frequency of 10th observation, 1.02 pi. So 2 pi minus 1 pi, it's pi plus pi times the relative frequency of 10th observation, 1.02 pi. Now we will take pi as common. So we can write 1 plus relative frequency of 10th observation, which is equal to 1.02 pi. Now this pi will cancel out from the both side. It will not cancel out. Basically what we do is we'll divide pi on the both side, and like pi will disappear, so we will left with 1 plus r10 equal to 1.02. So the relative frequency for the 10th observation comes out to be 1.02 minus 1. Therefore relative frequency for the 10th observation equals to 0.02. This is the